Question number 56 is given here. If solubility product of A3B2, a salt is given, is K, then the solubility of A3B2 will be. Solubility product is given for this particular salt, that is K, and on the basis of this you just have to find out the solubility also. In this question we have A3B2 as the salt, and on dissociation it will form 3A2 plus and 2B3 negative. Let's assume the solubility is S. So this K value is equal to 3S raised to the power 3 and multiplied by 2S raised to the power 2. And if you solve this, it would be 27S cube into, it would be 4S square. That would come out to be 108 S raised to the power 5. And what would be the value of S here? This would be K upon 108 raised to the power 1 by 5. And you have the value here for the solubility. You can easily choose the correct answer. That is option 4. Now, answer for this question is option 4. And yes, it's a turn for question number 57. Question number 57. Unit of equilibrium constant Kp for the given reaction is. And the reaction is PCl5, that is getting changed into PCl3 and Cl2. You should know that whenever we talk about the unit of Kp, that is equal to atmosphere raised to the power delta Ng. And the simple question is there. You can easily find out this value of delta Ng. That would be 2 minus 1. That is 1 only. So what would be the unit of Kp? That would be atmosphere only, ATM. And that's why the option 1 is correct for this question. And after this, it's a turn for question number 58. Conjugate acid of HPO4 2 negative is. We have different options given here, and when we talk about the conjugate acid of a particular species, the species here HPO4 2 negative, its conjugate acid can be formed by addition of 1H plus ion to it, and ultimately it will change into H2PO4 negative. And if this is the conjugate acid, easily you can choose the correct answer. That's given in option 1. And that's the answer for this question. After this, it's a turn for next question. Select the correct relation of interaction energy of dipole-dipole force in stationary polar molecule with internuclear distance, that is R. So we should know that the relation between the interaction energy of dipole-dipole force in stationary polar molecule is inversely proportional to R cube, where R is the internuclear distance. And if it is so, you can easily find out the correct answer is given in option 3, and correct answer is option 3. Now, after this, question number 60 is given here. Question number 60. A certain gas takes 8 times as long to effuse out as compared to hydrogen gas for same volume at constant temperature and pressure. Its molecular mass will be. In this particular case, we have the conditions which are same constant temperature and pressure we are considering, as well as we have two gases. One is a certain gas, unknown gas, and one is the hydrogen gas that we have here. And both of these have the same volume that we have taken here. So in this case, we have to consider the Graham's law of diffusion. Because we are talking about effusion, we can easily follow that law. The rate of effusion is inversely proportional to root of molar mass of the gas. Now, in this case, we are considering the same volume. Say, the volume of that gas is Vg and the volume of hydrogen is VH2. These two are same. As well as the time taken by the gas to effuse is Tg, let's assume, and it is 8 times
to the rate of effusion of hydrogen gas. This is the fact that is also given here. And now we just need to find out the molecular mass of that particular gas. That's a question. So in this case, we should always know that the rate of diffusion of that gas
and rate of diffusion of hydrogen, we are comparing these two. Those are equal to volume of the gas divided by the time taken by the gas to be effused, as well as it's divided by volume of hydrogen gas divided by the time taken by hydrogen to effuse. Further, it is equal to the root of molar mass of hydrogen upon the molar mass of that particular gas. This would be the formula that we can follow here. And now let's place the values here. If we talk about Vg and VH2, those two are equal, so these can be cut. And finally we have this TH2 upon Tg, and that should be equal to root molar mass of hydrogen upon molar mass of that particular gas. And what we need to calculate? We need to calculate molar mass of that certain gas. So here, in this case, this TH2, we already know that TH2 is Tg upon 8. So in this case, if we place the value, this Mg would comes out to be 8 square into the molar mass of hydrogen. What's molar mass of hydrogen? That is 2. So simply it would be 64 into 2. That is 128 gram per mole. And if it is so, the molecular mass is 128 U, and correct answer is option 4. After this, it's a turn for question number 61.